Hello world, welcome to Gamedev The Hard Way. If you've seen other episodes, this is my attempt to make a game from scratch for a retro-inspired computer called the Agon Light. When I say from scratch, I literally mean that. All the code is written by me with no existing libraries, and I'm doing this the actual hard way, just using C and a bunch of overly complex tools that I've also written myself. Today, I'm going to try the seemingly simple task of making an enemy that patrols across the screen. But along the way, I'll uncover some quite serious flaws in how my game actually works. So let's have a look. To keep all my code organised, I keep it in it's not a GitHub repo, it's actually GitLab, and I've got my own installation of it running on my own server. So this isn't public, and I don't keep it on GitHub. Not because I'm precious of my code, but mostly because some of it's a bit of a mess and I'm still trying to figure out what's going on whilst I write it. So I've got a new branch here that I'm going to put all my code into so that when it's done, I can just merge it with the main one and it's done. The issues system is something I also make use of in GitLab. It helps me keep track of what's going on. I've got a bunch of things here, and basic patrolling enemy is what we're working on. If I have one place to store all my thoughts and code ideas, I'll go back there and I won't keep replanning things and forgetting what I've written. So I'm just going to draft out what I want this thing to do. So something I'm trying to work out is how best to do all the various state machine behaviours that each sprite is going to have. I don't want some massive state machine that's really complicated. I want to keep it simple, but I still need to be able to make it work. Currently I've got this sprite animation state structure that is mostly just used for making the sprites animate, and I need it to do more things. It needs to do different pieces of code. At the moment the code is a bit of a mess. I'll show you what I've got. Here's the code for making the player work. I've split it into various little functions. I've got this piece of code that I don't think it's very good. I need to work out a better way of working out which direction the player is looking. This is the main update function, and what it does is works out which button you're pressing and then makes the player move in that direction. And it's got this set behavior function. All it does is currently sets this behavior variable and then selects the correct frame of animation. It doesn't do anything else. In my head I have this as some sort of state machine that the sprite can be in different states. So if you get hit and you lose all your health, you go into the death state, and if you're an enemy and you move left and hit a wall, you might choose to turn around and go the other way, or do something else that's appropriate for what your behaviour should be. That's partly what I'm trying to figure out in this piece of code today. What I'm really trying to avoid is code that looks like this, where there's a switch statement, a bunch of cases, and then just lots of code that gets quite complicated and hard to cope with. And I want it to switch from this state to this state, but I want it to take a few seconds to look nice. And so I have another state that's got a timer in it, and it's all just a bit of a mess. I'm hoping that by doing it for an enemy, I can then reuse that code or the idea for everything else that needs to have some sort of state behind it. It's kind of easy just to start making things up as you go along, doing what seems either easy or logical, just kind of hacking code together, seeing what comes out the other end. However, it's often good to do some research first. Doom was a game I enjoyed as a kid, and its source has been extensively documented. It's freely available on the internet for you to look at as well. And some really useful people have created a thing called the Doom Wiki, which has got some really interesting ideas on it. So because id Software uploaded the source code to GitHub, I can also just go and look at it. I'm not actually going to use their code, but it can be really helpful seeing examples of what people actually did. Seeing the source has given me some insight into what variables are named, how different parts of the system work together, and just in general, what the code itself looks like. Since if you're coding away by yourself with nobody else, you kind of wonder whether you're doing it your own weird little special way that you've just made up, or whether you're actually doing things that other people do. So it's kind of fun to see if your coding style matches anyone else's. What I've noticed from looking at the Doom source is that it was coded by people who clearly learnt assembly as their first language. The structure is very it's hard to explain, it's very kind of robotic and precise, very declarative. There's variables that are set, there's if statements that are checked, everything is very short and to the point. I learned how to write BASIC first, then I progressed to Pascal and C. So my style of code is more kind of procedural, and it has a light sprinkling of object orientation in it. Also, since I did a software engineering degree, I tend to over-engineer my code, rather than trying to make it simple and short. That's partly why I'm writing this game from scratch. I want to improve my own programming skills. Can I cram a fairly complicated game into a simple machine? It's been a while since I looked at this code, so to get back into it, I'm going to start with some very simple tasks. The things I need to do are, first I need to spawn an enemy on the level. I then need to define a thing called a thinker and attach it to the enemy so that it does something. I then need to make the enemy move left and right across the screen. Seems fairly straightforward. This shouldn't be too difficult, I hope. Now, a thinker is a concept that I've completely stolen from Doom. It's their way of attaching code to a game object. Doom is sort of like a cooperative multitasking environment, and each enemy, door, and other item that needs to run code is assigned this thing called a thinker. This is a structure that contains a callback function and a bunch of other stuff that does the same sort of thing as my update callback, only it's a little bit more thoughtful and packaged together. It's a bit involved trying to explain it here, so I'll write a blog post explaining the whole concept and how I'm using it, so look out for that in the description below. I'm going to write the code to spawn an enemy on the level so I can tick this one off. This shouldn't be too difficult because I've already got a player, so it should just be pretty much the same code. And yes, the observant of you out there will notice this is Windows and this isn't Linux, and this is Visual Studio Code and it's not Kate. No, I haven't ditched Linux or anything, I'm just on my other machine. I have this so I can develop on my Windows machine, or my Surface Pro, or my Linux machine, so that I can do development wherever I feel like doing it. What I need to do is first open up the level and work out where the enemy should be. I think I've already got one on this, and I just need to work out where I put it. So yeah, there we go. So on the second screen across, so I start on this screen, there should be an enemy once I've told it to appear. Now, someone pointed out that I don't have to do grids like this for each room, and that is very true. This is just that I can check that the screen switching is still working. So in this second screen, there should be an enemy. So it's got a name of enemy 1 and a class of enemy 1. And it's got an X or Y position. Something I did to the code is this Gamedev structure. So I've got this entity def, which has got the name of the thing. It's got some data about it, its default behaviour, which I'm not really using, and then a pointer to the actual sprite definition for that type. I'm then making use of enums, so I've got one for a player, got one for an exit, and I've got one for an enemy 1. And then this is extra stuff that you'll see as I write more code. Inside here, I'm now defining what the update function for the player is, for the exit, and this first enemy. I'm also then defining data about each entity that's going to appear on the map. Now it might look from this code that I've already got this working, like it says enemy 1 here, there's one in the map, and surely that just means if I run the game, half the code I needed to have written is already there, and I'm kind of wasting a bit of time. Well, not entirely. If I comment this out, so we don't have a definition for what enemy 1 is, and I'll get rid of that as well. And then we'll go into gamedev.h and we'll comment that out. So now it doesn't know what enemy 1 is at all. Let's try and compile this. So you can see it's loading up, it's loading the font, it's doing some debug printing. It all appears to be working fine. But then when I start the game, it quits and it says try to instantiate sprite called enemy 1, which does not exist. And then it quits and it tells me where it quit. So mob.c, line 19. Let's go look at mob.c, line 19. So mob.c, line 19, that's where it asserted. Because we tried to instantiate something called enemy 1, and it's not in the list of entities that exist, because I didn't define it in here, and then I didn't define all this extra stuff. So I've added a bunch of debugging code. What I've done is I've added an assert function that will print out some text. And I totally just stole this off the internet. This is fairly standard looking code, I think. And then I've got a game print thing to print some text on the game screen as well. But this now just means that instead of there being parts of the game and code where I didn't know quite what to do if something went wrong and it just sort of returned 1 and maybe it broke later on, it'll now quit with an error message. For example, if I go into something that loads in assets, this is the code responsible for loading in sprite definitions. And this is a piece of very fundamental code. If it doesn't work, the game is not going to function no matter how cleverly I handle this error. So I may as well just die instantly. Same with if I can't open the file, or if the file is not the correct thing. So adding small things like this has made the code much easier to debug. It means I'm spending less time guessing why it's not working and more time actually fixing it. If I've put the code back together, it should still compile and then it should run without crashing, and we should be able to go and find that other entity. Right, let's have a look at what happens. So there's the player. The gameplay feels very jerky and slow. I'm not sure if that's just the emulator on this particular machine, or whether it's actually the game itself. Aha, there we go. So this pointy arrow thing is the other enemy. Now what happens if I run into it? Because it's a physics object, the same as me. Oh, I can push it around the screen. That's good, that means the physics engine knows about it. It feels very floaty. I am at some point going to have to run this back on the real hardware just to see how it actually operates, to work out whether this is an emulator that's been slow, my PC being slow, or just my code is horrific. A lot of the flashing and flickering is the emulator. Right, well that was fairly easy. I've done that one because I didn't actually have to do anything. I just wasn't sure if it was working, but it is, so we have spawned an enemy. If you're enjoying this video, consider hitting the subscribe button that's down below. Don't rely on the YouTube algorithm deciding that my future videos are worth watching. Also, I think it'd be fun to try and hit 50,000 subscribers, so help me by doing that. Also, if you feel like supporting the channel, which is totally optional, take a look at my Patreon. Members get ad-free versions of the video earlier than it appears on YouTube, and you also get a longer, more detailed video that's a week or so before it appears on my second channel. I kind of heavily edit this video to make it more appealing to general YouTube. There is a longer version that goes into more detail, so you can watch that if you want to. Either way, it's appreciated having you around, so let's continue. Right, next on the list of impossibly easy tasks is defining a thinker for the enemy and attaching it to the enemy. Now, through the magic of forgetting to hit record, I've already done this. And what I did was I created a new file called enemy.c and enemy.h, which is pretty much just a copy of the player. You see, look, player update has become enemy update. And then inside here, we've got a function, and it doesn't do anything. And then inside Gamedev, I simply linked it inside this update function list so that it knows how to use it. That's it. This is how easy writing some of this code should be. I should just define things, attach them where they need to go, and not have to dig around in pages and pages of code, adding lots of extra stuff. So I can still move around. Collision detection isn't broken. There's the enemy, and it does nothing, because it's running code but it's not actually doing anything. Something else that I quite like that's a bit accidental is if I switch into the game, you can see it redraws the screen tile by tile. I like the way it draws it tile by tile. I think I want that as the actual effect between screens. It looks kind of cool. This screen also needs completely fixing, because apart from like doing this weirdness, whenever I go back in, it completely resets the game, which makes it pointless for debugging. Like if I was over here debugging something, and then I look in here to see what was written, and I get a Facebook message. When I come back, the game is reset. Kinda need to fix that. But anyway. So I know it seems a bit pointless that I've made these two to-do list items, and pretty much I didn't have to do anything to make them work. But that's just how my brain works. Like, that's the easiest thing I can think of doing first, is just make a thing appear. And then the next thing is just to attach a function to it. It's that way of like getting started on something that feels a bit difficult and you don't quite know where to start. Pick an easy thing, pick another thing, and then you'll be sort of in the right frame of mind to do something that's a bit more complicated. Like, I'm not quite sure how to do the left and right patrolling. Like, obviously the sprite just needs to move one way. When it collides with something, turn around and go the other way. Just like the bouncing DVD logo kind of thing. But I don't have anything in my code that lets me do that. There's no way of the enemy actually knowing if it's hit anything. Now what I mean is, inside the bowels of the physics code, there is this concept of a physics body. And it does some axis aligned bounding box collision checks. And then it corrects itself if it's trying to go inside a wall or something. So it's resolving tile collisions. So when the sprites are being updated, they first update the physics, and then they deal with collisions on the map. And they resolve the collision so it's not overlapping a map area. Not overlapping a tile on a map. Once it's resolved the collision, it then calls this collision function. And this isn't really the right way of doing it, I guess. I should just set a flag so that the sprite inside its thinking function can tell if it's collided and do something about it. Otherwise, I've got a piece of code to deal with colliding with stuff that's a separate piece of code to do with just existing and thinking by itself. The two should be like the same thing. So I need to fix this. And this is how like writing code like this works. You set off to do something simple, and you end up rewriting half the engine to actually, now you re-understand and properly have figured out what's going on, you need to refactor everything. But that's kind of the fun of doing this stuff. I don't know what I'm doing, and I'm kind of figuring it out as I go along. It's a general theme of what I do. I know some people think that that's a bit rubbish, but go try making a game yourself and see how far you get before you hit something that you just do not know how to do, and you have to bodge something just to get an idea, and the process of bodging it helps you figure out what you're really trying to do. It's that style of I don't know what I'm doing. It's not that I'm a completely clueless idiot that doesn't know what's going on. It's just I don't quite know how to tackle this particular problem just yet. I will fix it, it just takes a few attempts. It just occurred to me that whilst trying to debug this, if I've got the enemy on a different screen to the player, it's going to be doing things and I can't see it. So it might just decide that it's going to wander across here and invade this screen and wander off before I've even blinked. Or go this way and I'll never see it. So I need to put them both on the same screen so I can watch them. So I'll move the player onto here. We'll save the map. Now we'll just run it to check that it's not broken. So I should now just be on another screen. And I am. That's wonderful. That right there is why I bother doing all this code. I don't have to edit anything at all. I just open the level editor, put the sprites where I want the sprites to be, rerun the code. It's there. It's done. That's what all this effort is for. It actually makes creating a game easier. Currently, my code makes use of lots of different callback functions. I've kind of gone mad with that design pattern, and I think it's causing me lots of trouble. Because there's one that gets called every time a sprite needs updating, and then there's a separate callback now for when a collision happens. Which seems a bit redundant, because thinking more about the way the code works and how I actually want to use it, doesn't make much sense to have two places where game logic lives. Because what if when I have a collision, it means the sprite needs to alter its current behaviour, like it's got some sort of state machine and it needs to change states. Because they're in separate functions, I'm going to end up inventing ways to sort of communicate between the different update functions and kind of defeating the design of my own code. So instead, I need a better way, and one that seems quite sensible is just to set a flag when a collision has happened, and then in the update function, test for that flag and react accordingly. So what I'm going to do is add a flag to say what the current sprite has collided with. Currently I'll have collisions with other sprites and also with walls and floors and stuff. And then if it's a collision with a sprite, I can just set a pointer to which sprite was involved in the collision. That way if I collide with an enemy, I can work out what kind of enemy it is because maybe they do different types of damage or something. Or if I'm just colliding with something to collect, I know not to actually do anything to myself and to maybe get a new weapon or something. Now, when I run the code, I've noticed something kind of weird. The game thinks the sprite is colliding with the wall when it clearly isn't. So I guess we're off on a side quest to find out why. It's confusing, so while I try to work out what's going on, I'm just going to make sure the other collisions do work and that I've not completely broken all the code. So as you can see, the sprites do correctly collide and the game knows about this. I have an idea that maybe it's happening before the game starts. Maybe it's some kind of initialization issue, where like, I don't know, maybe some values are not set correctly, and there's a few game loops happening where things are colliding when they shouldn't before it all gets reset and updated properly. So if I run the game, is there a collision logged before anything actually happens and even has a chance to start moving? It looks like collisions are happening, but I can't work out who is colliding with who. So I need to just add the sprite ID to the debugging so I can actually work out what's going on. That's helped quite a bit, but it's now showing me a new bug where every time I open the debug screen, it effectively restarts the game. I already kind of knew this was a thing and was mostly ignoring it, but now I'm printing out sprite IDs. I can see there's another bug where every time I restart the game, I'm not resetting the sprite system, it's just making more sprites and kind of ignoring the old ones. This is proving to be quite frustrating and annoying. What seemed like a simple task is riddled with problems, nothing's working, and I appear to have made the whole code far worse than it was before. You know, if it's not broken, fix it until it is. Still, I'm going to keep grinding away at this step by step until I either find something actually wrong or I work out how to do this properly. What I'm about to do is ultimately a little bit pointless. It doesn't end up fixing the issue, but the process is still very useful. Programming is kind of like this. I know there's a problem, I need to find out what the problem is, then I need to understand why the problem exists before I can even start trying to fix it. It's slowly starting to dawn on me that maybe my physics code and the way I've integrated that with the map system is the actual problem. And I need to go back and think about this a little bit more. So let's go watch me fumble around in the dark for a bit more, because you know it's kind of entertaining, isn't it? Why does it think it's colliding with a wall when it isn't? It's a good question. Let's find out. I know why it's happening. It's because this piece of code is running. So what's making that piece of code run when I've put the sprite in the middle of a room and there's no wall right next to it and it doesn't move? I wonder if it's something to do with the way the game logic runs at the very start of the game. Maybe for a few frames it's actually, I don't know, 0, or something. Right, let's run this, see if it works. Right, so it's happening after it's been instantiated, so it should be at the correct place. It feels like there's something wrong with the logic of this function. Just doesn't feel right. Right, I think I've worked this out. If you look at this text here, it says sprite 2 collided with the wall quite a number of times. If we actually look at the code, in here, I put this piece of code that says sprite C collision with wall, and it's not printing this at all. If we look at what enum collision wall is, it's 0, and then collision other is null because it's not needed. But then if you go into earlier part of this where we're initializing sprites and instantiating them, we set everything to be 0, which means we're setting the collided with to 0. So I think I need to adjust that enum. Right, that's better. It doesn't think it's colliding with anything anymore. But now if I go down here, I bang into this thing, that should have triggered a few collisions. Yeah, so sprite.c, 3 collided with wall. No, it didn't. 5 collided with sprite 3. Bang into you. So 11 collided with sprite 9. Because there's a bug with how we create the sprites, but never mind. I don't know I have to whack that so many times to make it work. But I have to bang into the wall. Yep, good. Now I've done that little side detour. Programming is just full of little side quests that you've got to go and fiddle with just to get the main thing working. Let's now try and just make this enemy move left and right across the screen. This shouldn't be too hard, it's just bits of this player thing. I need to store the current movement direction though, so I need to add something somewhere to store this. I'm going to add it to the entity definition and set up some suitable defaults. So for now, I'm just going to bodge this by hand by manually shifting the number 1 a few places to fit with my floating point fixed point system. I just want to see if this code even works before I get too invested in it. Of course, it helps if you remember to actually update the physics engine with your new velocity as well. And it also helps if you actually initialize the sprite correctly when it's being instantiated. This code's a little bit of a mess. So yes, I've added this, but I'm not doing anything with it. It then does seem to move briefly, but stops. Looking at the debug log, which is proving to be the most useful thing in this game, it shows some very odd numbers for the velocity. I think this piece of code is pretty knackered, and I really need to redesign it. I think at this point I'm just kind of hacking things now, no longer really thinking about what I'm trying to do, and I need to just stop and step back a bit and have a look at what's going on. I've run out of time for this now. I was kind of hoping to show you some more actual game-like code instead of just me fussing about with buggy, poorly designed code that doesn't really work. However, that's just how programming is at times. If I knew what to do, there'd be no challenge and it'd just be a case of typing out the code like I'm writing a book or something. I'm going to go away and have a proper think about how to structure my code. This hasn't been a waste of time or effort at all. I now understand what I'm trying to do a little bit more, and how I need to now research how others have managed to integrate a physics engine with other game logic. While I don't know how to solve this myself yet, it seems to be the sort of fundamental functionality others must have solved in the past. Today, we just open Unity or Unreal, and all this is hidden away. But in the 90s, people really were writing code like this by hand. It was the hard way, or you didn't write games. So I'm off to read what they've written down, trail through some ancient text files hidden away on the Internet Archive, find some dodgy scanned PDFs on Russian websites that contain long out-of-print books, and when I've found all that stuff, I'll see you in the next video, and we'll see what I get up to there.